is 0 doesn't mean the velocity is 0. Okay, so it's saying, can you have a non-zero velocity? In other words, it has velocity, but a 0 acceleration. All right, an example of this is cruise control. Okay, when you get on the highway and you put your car on cruise control, you're moving, right? So you have a non-zero velocity. So you have a velocity. But if you're not changing your speed, in other words, you're cruising at the same speed, you remain at the same speed, you have 0 acceleration. Your speed is not changing. So in that case, it's possible to have a non-zero velocity, but a 0 acceleration. All right? So let's look at number 5 here. Number 5, it says, an automobile is moving to the right along a straight highway. If we choose to be the positive x direction, then the driver puts on the brakes if the initial velocity is VI 15 meters per second and it takes 5 seconds to slow down to VF equals 5 meters per second. What was the car's acceleration? So again, let's draw this out. Car is going this way. We'll set this way to be positive, this way to be negative. The initial velocity here is 15. Yes, 15 meters per second. The final velocity is 5 meters per second. It says in a time of 5 seconds. Okay? So it's moving in the positive direction. It asks me what's the acceleration. So let me write these variables down. VI equals 15, VF equals 5, T equals 5, and A is what I'm looking for. So what's happening here is it has a positive velocity slowing down. To slow down a positive velocity, you need a negative acceleration. So the answer we should get here should be negative. So let's go ahead and look. I have all these variables. I look at my equation sheet. I try to figure out the equation that only has these 4 variables in it. So once I figure that out, I go ahead and write that down. I looked at my equation sheet. I'm going to use this equation here. VF equals VI plus AT. I plug in. VF is 5. VI is 15 plus A is what I'm looking for, and T is 5. Okay, so all I did was plug in. Next thing I'm going to do is solve. So I'm going to subtract by 15. So I get negative 10 equals A, 5. Divide by 5. A equals negative 2 meters per second squared. And as you can see, we did get a negative answer because you are slowing down a positive velocity. So the acceleration vector is that way. All right? All right, 6. It says, you were designing an airport for small planes. One kind of plane that might use this airfield will reach a speed before takeoff of at least 27.8 meters per second. It can accelerate at 2 meters per second squared. A, if the runway is 150 meters long, can this airplane reach the required speed for takeoff? B, if not, what minimum length must the runway be? Okay, so let's look at the first scenario here. All right, first scenario. Let's imagine that the airport is only that long because it goes off a cliff, like James Bond, GoldenEye. I don't know what I mean. You guys are probably all too young to have seen that great James Bond movie. All right, at the beginning of the thing, he gets in a plane and the runway ends and he goes off the runway, but he's James Bond and he clutches it. All right, so we're kind of going to do that. So an airplane here. Airplane. It's going down the runway. The runway, it says, is 150 meters. All the planes start from rest, so initial velocity is 0. It says the plane can accelerate at was it 2 meters per second squared. So it speeds up at 2 meters per second squared. It needs to reach a certain final velocity. So what we can do is, if we can calculate the velocity it reaches, or it gets to when it reaches the end of the runway, we can then compare it to see if it's going fast enough to take off. So what we want to find is, if we can find velocity final here, we can then compare it to that 27.8. If it's greater than 27.8, it'll take off. If it's less than 27.8, it's going to go over the edge. All right?
At this time, everyone please return to the building. Everyone please return to the building at this time. Thank you.
So let's go ahead and look at this and see, list our variables and go from there. So I got VI, I'll go ahead and write it, VI equals 0, A equals 2, delta X equals 150, and I'm looking for VF. So we got to this point where we have 4 variables. Again, look at your equation sheet. Which equation are you going to use? It's going to be one of these 4 right here. It looks like we don't have time, so it's going to be the one without time. And that one's going to be VF squared equals VI squared plus 2A delta X. Okay, that's the equation we want to use. Now all we got to do is plug in. VF is what I'm looking for. VI is 0, so it goes away. 2A, 2. Delta X is 150. Solve. So I got VF squared. So I do 2 times 2 times 150. Let's see. 4 times 150 equals 600. I square root. I get 24.5. My velocity final here is 24.5 meters per second. It's obviously less than 27.8, so plane will not take off. Alright, plane won't take off because it doesn't reach the necessary velocity required. So now what it says is, so this is part A. Now what part B says is, how long does this actually have to be? Okay, so it's no longer 150 meters, we need to figure that out. Okay, we need to figure out, okay, delta X, how far is that runway going to be so this plane can take off? Well, we know to take off, it has to reach a speed of 27.8 meters per second. So that's the speed we need to reach here. So for this part, okay, we know it has to reach this speed. So my VF is 27.8 in this case. Okay, so I'm changing this, part B now. Okay? So now, does my airplane still start from rest? Yeah, it still starts from rest. VI equals 0. Does it still have the same acceleration? Yeah, the engines stay the same, so A is 2 meters per second squared. But this time, I know velocity final. It has to get to that velocity. So I go velocity final equals 27.8. I'm now trying to figure out how long that runway has to be for it to take off. So I can go ahead and solve for that. I do the same exact thing. Okay, which variables do I have? I look at my equation sheet. I'm actually going to use the same exact equation. So I go VF squared equals VI squared plus 2A delta X. I plug in. VF is 27.8 squared equals VI 0 goes away, 2 delta X. I can square 27.8, so I do 27.8 squared. $772.84 equals 4 times delta X. Divide by 4, divide by 4. I get delta X equals 193.2 meters. So the runway for this plane to take off needs to be a minimum of 193.2 meters. Okay? Good. Alright, good. So let's go ahead on to number 7. Alright, so it says, how long does it take a car to cross a 30 wide meter intersection after the light turns green if the car accelerates from rest at a constant 2 meters per second squared? Alright, so here's what we're going to do. We're going to imagine this, okay? Car is going through an intersection. There's the intersection, car's coming through it. It's 30 meters wide. Starts from rest. And it accelerates at 2 meters per second squared. We want to know how long does it take. So in other words, what time. So list my variables again. VI is 0. A is 2. Delta X, 30. Looking for time. Okay? So I look at my equation sheet again, figure out what equation you use. You're going to use this one. Delta X equals VIT plus 1/2 AT squared. Plug in. Delta X is 30. VI is 0. 0 times anything. It doesn't matter what the time is. If VI is 0, that cancels that whole thing out. So I'm left with 1/2 A2 T squared. So 2 times 1/2 is just 1. So I get 30 equals T squared. Square root each side, square root each side. T equals 5.47 seconds. That one's pretty straightforward, pretty easy. Okay? Good. Okay, moving on. Number 8. A car traveling 85 kilometers per hour strikes a tree. The front end of the car compresses and the driver comes to rest after traveling 0.8 meters. What is the average acceleration of the driver during the collision? Okay, don't worry about the second part. That's just comparing it to the force of gravity. You ever hear G's, like an astronaut goes under